Title of the project: Animal Intrusion Detection and Alarm System. Team members: S. Vijayaraghavan, T. Vaikitan, C. Vivekanand. Area of project: Embedded Systems and IoT. Our project uses a Raspberry Pi 3, which is an embedded system capable of processing sensor data and sending alerts. IoT, Internet of Things integration, can be added for remote monitoring. Wireless communication and automation. The project includes an SMS alert system, which falls under wireless communication. Additional automation, like activating deterrents, lights, alarms, or sound systems, can also be implemented. Problem statement: in agricultural fields, wild animal intrusions pose a significant threat to crops, leading to financial losses for farmers. Traditional methods such as manual monitoring and fencing are either labor-intensive or ineffective in preventing such intrusions. In rural and forest-adjacent areas, the intrusion of wild animals into human habitats, farms, and roadways poses significant risks to human safety, agricultural productivity, and wildlife conservation. Such incidents can lead to crop destruction, livestock loss, traffic accidents, and dangerous encounters between humans and wild animals. Traditional methods of monitoring, such as manual patrolling or fencing, are often inefficient, costly, or impractical for large areas. There is a pressing need for a reliable, real-time, and automated system that can accurately detect the presence of animals and alert concerned authorities or residents before any damage occurs. The Animal Intrusion Detection System, AIDS, aims to address this challenge by employing technologies such as infrared sensors, thermal imaging, camera vision, or machine learning to detect, classify, and notify about animal movement across restricted or vulnerable zones, minimizing human-animal conflict and enhancing both human and animal safety. Literature survey. AIM. The aim of the Animal Intrusion Detection System is to monitor a crop field or restricted area using a camera-based AI model to detect and identify animals in real time. Upon detection, the system will trigger alerts via SMS, sound alarms, or cloud notifications to prevent damage. This solution enhances farm security and minimizes human intervention, ensuring timely action against animal intrusions. To design and develop an intelligent animal intrusion detection system that can accurately detect and identify the presence of animals in restricted or sensitive areas using sensor-based or vision-based technologies, and generate real-time alerts to prevent human-wildlife conflict, crop damage, and property loss. Objectives: an animal intrusion detection system aims to identify and monitor the movement of animals in restricted areas such as farmlands, highways, and forests. The primary objective is to prevent damage to crops, property, and infrastructure by providing early warnings to farmers, security personnel, or conservationists. By ensuring real-time detection, the system helps in reducing human-wildlife conflicts and minimizing risks to both animals and humans. Automated alert mechanisms, such as SMS notifications or alarm systems, enhance response times and improve overall safety. Detect animal intrusions in real time using images. Classify the type of animal using AI. Send alert messages to nearby community members. Store images and information securely for review. Abstract: agricultural fields often face significant losses due to animal intrusions, which damage crops and disrupt farming activities. This project proposes an AI-based animal intrusion detection system using Raspberry Pi and a camera module to monitor the field in real time. The system utilizes pre-trained deep learning models, YOLO Mobile Net SSD, for object detection, enabling accurate identification of animals such as deer, wild boars, and stray cattle. Upon detecting an intrusion, it triggers an SMS alert via a GSM module, activates a buzzer or flashing light to scare animals away, and can also send notifications via Wi-Fi, Firebase Telegram API. Introduction: this project focuses on designing a smart intrusion detection system using Raspberry Pi 3, equipped with motion sensors and an SMS alert system. The system automatically detects an approaching animal and sends an immediate notification to the farmer or security personnel. This not only helps in reducing crop damage, but also ensures better human-wildlife coexistence by enabling timely interventions. Advanced versions of such systems integrate AI-based image processing and IoT to enhance accuracy and efficiency. By implementing this technology, the project aims to provide a cost-effective, real-time solution for agricultural security and wildlife protection. Unwanted animal intrusions can damage crops, threaten communities, or cause accidents. Traditional monitoring methods are not effective at night or in remote areas. Our solution, an automated system that detects animals and sends real-time alerts. Workflow: image captured and sent to PC processes. The image detects animal using ML model, sends alert via SMS or WhatsApp, stores image on Google Drive. Existing system: currently, several methods are used to prevent and detect animal intrusions in agricultural fields. These methods include manual monitoring, fencing and barriers, scare devices. Proposed system: an automated animal intrusion detection system using Raspberry Pi 3 is proposed. This system will use sensors, image processing, and real-time communication to detect animal movement and notify farmers immediately. Real-time animal detection, automated alert system, cost-effective and scalable. Components: hardware, Raspberry Pi, 3B Plus, mobile camera, PC, SD card, power supply, buzzer, sensors. Optional software: Python, YOLOV 5, Flask, MySQL, Twilio, Firebase. Machine learning model, YOLOV5, trained on custom animal dataset. Dataset contains labeled images of animals common in your area. Output: animal name confidence score bounding box on image. Alert mechanism uses Twilio for SMS notifications, Firebase or WhatsApp API for community alerts. Sends animal type, time of detection, image link, Google Drive URL. Results: successfully detected multiple animal types, sent timely alerts with images, stored detection records for analysis. Challenges faced: Raspberry Pi limitations for running, PyTorch models, camera module failure, used mobile images instead, image transfer and latency issues. Future scope: the animal intrusion detection system can be improved with advanced AI models for more accurate detection and classification of animals. Integrating night vision cameras and thermal imaging will enable detection in low light conditions. Automated deterrent mechanisms like sound alarms, water sprayers, or drones can help prevent animal entry. IoT and cloud integration will allow real-time remote monitoring and predictive alerts. Future enhancements like GPS tracking can help analyze animal movement patterns for better farm security. Add night vision or thermal camera support. Run model directly on edge using TF Lite, improve accuracy with larger dataset, real-time dashboard for authorities. Application: crop production, livestock safety. High animal detection, railway track monitoring, preventing human-wildlife conflict. Conclusion: the animal intrusion detection system provides an efficient and automated solution to protect crop fields from animal attacks using AI-powered camera surveillance. By detecting intrusions in real time and triggering SMS alerts, buzzers, or deterrent mechanisms, the system helps farmers take immediate preventive action. This reduces crop damage, minimizes human effort, and enhances farm security. With future advancements like night vision, IoT integration, and automated deterrent systems, the project can become even more effective and scalable for large agricultural areas. Developed a cost-effective, scalable system, helps farmers and communities stay safe, blends AI, IoT, and community collaboration. References: